Optimization problems involve finding a minimum or maximum value of a function on a given interval. So these will typically be presented as worded problems, and you'll interpret those worded problems into functions. And in general, the function you'll be dealing with is a function of an independent variable, and it can also be a composite function of a dependent variable y, which is also a function of the independent variable x. And to find the minimum or maximum value of the function we're looking for, we differentiate it and set the derivative to 0. So that gives you your critical point, and then you can differentiate again, assuming that the function is twice differentiable, and check if the second derivative is less than or greater than 0 to determine whether the critical point is a local minimum or maximum. So the optimization problem may also be subjected to a constraint. So for example, you may be restricted to some interval over a function's domain. So here is a typical example. So if we have the dimensions of a rectangle, and if we restrict the perimeter to be equal to 100, and what we want to do is maximize the area. So the area is xy. So as we can see, it's a function of x and y. And you'd solve this equation for y or x, and then substitute into this expression, and then you're able to evaluate the derivative and set it to 0. And that's going to give you the minimum or maximum value, which you can check using the second derivative. A builder has 40 meters of fencing to fence off 3 sides of a house. And what is the maximum area of the land that can be fenced off? So if we denote the horizontal dimension as x and the 2 vertical dimensions as y, then the perimeter is x plus 2y, and that's equal to the amount of fencing we have, so 40 meters. And because we're asked for the maximum area, well, the area is x by y, and we can substitute for x, so we can write this as 40 minus 2y by y. So we can have the area as a function of one variable, and then we can differentiate the area with respect to y. So that's equal to 40 minus 4y. And then setting this derivative to 0, we get y is equal to 10 meters. And substituting for y, we can get x is equal to 20 meters. So therefore the maximum area of the land that can be fenced off is 20 by 10 or 200 meters squared.